I messed up so many times, and every time I say this, so I have like this paranoia where I go and check if we're actually live or
Right.
not. So that's what I'm doing right now.
Okay, no problem.
Let me just make sure real quick. I can hear myself. Awesome. I didn't mess up this time. Yay. Hey
Great.
everybody, thanks. Thanks for joining us live if you're joining live, and thanks for watching the recording. Thank you, Adam, for joining us in the evening. I know it's evening time for you.
Well, thanks for having me. I'm excited.
I'm excited to have chai in the morning. Usually I host interviews in the evening. I have flexible chai hour, so this is afternoon, but excited for the
That's good.
change.
Yeah. It's a bit late for me to start drinking caffeine, I think, but
4 p.m. is not that late.
I guess, yeah. I mean, I think it lasts like 7 hours in your body. So yeah, I guess I could go to sleep,
It does.
you know.
Good thing I didn't
That's
know
what
that.
I read that one time. It's not a fact. I'm not sure.
It's trust me, it's not good to read these things. I try not to.
Okay.
I didn't know until recently chai had caffeine, and I still don't believe that.
Sometimes I think it
Awesome.
has a stronger effect than coffee, but yeah, sure.
That I can agree on. So I'll quickly introduce the session, and then I'll start by asking Adam about his Suni. Let me quickly do that. So this is the 10th in the Chai Time Kaggle Talks. This is essentially Chai Time Data Science 2.0, where I invite my heroes and awesome Kagglers like Adam to tell about how did they get to the position of achieving a solo gold in a competition in just 1 year of getting started. The agenda for today is I'll introduce the session, which I'm doing right now. Then I'll ask Adam how did he get started. We'll try to understand the Jigsaw competition, and then Adam will tell us more about his solution. A little bit about Adam. He's achieved the rank of Kaggle Competitions Master, which arguably is one of the more challenging categories compared to the others. His blog, which you can find on his Twitter profile. If you go over there, it's pinned there, and his Twitter handle is a Montgomery underscore. His blog on Kaggle Journey to Competitions Master was quite well recognized in the community. Even the CEO of Kaggle tweeted it out. I would highly encourage you to check it out, and you can find him on Twitter at Montgomery underscore. So thanks again, Adam. I wanted to start by asking you at what point did you find yourself interested? I know you started in NLP. How did that catch your interest?
Well, yeah, I guess I took a kind of indirect route to getting into machine learning because originally I got a undergraduate degree in philosophy, which is kind of unrelated. And but after I finished that degree, I realized there's not many companies that are desperate to hire philosophers, really. So I thought I should do something a bit more practical, and I got a master's degree in computer science. At least in the UK, I don't know, maybe they have it in other countries too, but it's called a conversion course where even if you didn't have the right undergraduate degree, you can still sign up for this master's course. And we had to take some undergraduate classes and some classes with the master's students and get up to speed at the same rate as everyone else. So I learned a lot from that. It was hard work, but because of the short term nature of it, there isn't really much room to try different applications of computer science. So I never had any machine learning classes or really any maths or stats classes either, for that matter. So uh, I felt quite behind when I did get into machine learning. Everything was new to me, and after I graduated, I moved to Japan and I became an English teacher for a few years. Um, and then before finally the English teaching thing was only meant to be temporary, and I thought, okay, it's time. I'm going to look for software development jobs, but I didn't really have any particular skill set, and I would just apply for anything, front end, back end, whatever. But that attitude's not very good in job interviews. I don't know anything, but I'm willing to give it a try. So I thought I need to develop a specific skill set, and I thought if I could pick anything, what would be cool? And I thought, machine learning seems like a cool thing, so I'll start learning that. And when I found out about it and I started finding out about NLP, it kind of made sense to me because um, it's in some sense it's kind of a crossover of different things I've done before. There's some computer science and some language, and um, yeah, so it really got my interest, and I've been interested in it ever since.
May I ask, as a philosophy major, you must have been new to programming. How did you go about that? I know for a fact I've studied computer science. It didn't at all help me. People have this assumption that you need it to help you become a better programmer. How did you go about that journey of learning Python or even front end or all the software
Mm.
details?
Well, I guess I had always been into computers, and I had a few like programming classes before university, but not so much, pretty basic. And um, so for me, I don't know, it was always just about spending a lot of time messing around with things and practicing things. So I had already taken a few classes in learning Python and things. So when I started learning machine learning, that part didn't seem that challenging to me because it's just installing a few new libraries and learning a few new libraries in Python. But the challenging part, I think, is really the theory behind it. So when I first started trying to learn about machine learning, I took some, like courses on Udemy and Coursera and things like that. But I found it easy to follow along, and they say, okay, now we're going to install pandas, and now we're going to do this, and I can do it. But when I get to the end, and they're like, okay, here our model has made some predictions, and I thought, like, what am I doing? What does any of this mean? I don't understand what these algorithms are, and I don't understand what I've just predicted. So I needed a bit more theory, really, rather than learning programming was not such. I don't want to say it wasn't such a challenge. Of course it is. It's something that I still have to practice, but I think it's something, if you just do it every day, you get better at it. Whereas something that didn't come naturally to me was mathematics and statistics. It's always seemed kind of a bit more scary.
That's great to hear. In your blog, you mentioned you started with the TPS competition. Was that your start in the world of competing? I also saw. This is a silly question to ask, but I saw your picture holding an AirPods that you had won. Was that your point of addiction to competing in machine learning, or
Oh,
what's the
the
story there?
AirPods. Oh, these ones. Yeah. No, that was actually something. That was
Sorry, I went
something
over the
from
mic.
my.
My
Oh, sorry. That was something. That was just something from my current company. It was like an employee of the month kind of thing. They gave me some AirPods.
sorry, I assumed that was through a Kaggle or some form of competition. My bad.
No, it wasn't. No, yeah, I didn't get into Kaggle immediately. Of course, I was aware of it from when I first started getting into machine learning because it's a great resource and everyone knows about it. But I didn't really do anything with it at first, except download a few data sets. And I was mostly into like my own. I had my own ideas for side projects, things I wanted to do, and I would like collect my own data and train a model and things. What I think really got me into competing was when there was like a crossover between my own side project and a Kaggle competition. It was the Common Lit one, which was about predicting the reading difficulty of some texts. And I had been doing something similar on my own. It was a little different though. It was from the perspective of someone who's learning English as a second language, and I wanted to classify each text in terms of its CEFR level, which is the Common European Framework of Reference for Languages. I think that's what it stands for. But basically, it's a leveling system where you have some classes like A1, A2, B1, B2. So I made some classifiers like that. But then I saw the Common Lit competition, and they were doing something similar, just predicting American grade school reading levels instead. And I thought, oh, this is great. Like I've done a bunch of research about this, and I've already trained some models, so I can just jump into this and give it a go. And it turned out that most of the things I didn't translate very well into this competition because this one was framed as like a regression task instead of a classification one. But it got my interest, and I guess because it related to NLP and it related to education as well. Like I'd worked as a teacher for a few years, so this kind of problem was naturally interesting to me as well. And I got quite high up the leaderboard early on, And I didn't really realize at the time, but I was basically just overfitting the leaderboard. But I think that that's kind of like a rite of passage for new Kagglers, right? You know, you go up the leaderboard, and then the private leaderboard's revealed, and you come crashing down again, and you learn to be a bit more humble. But I got lucky in that competition because I was high on the leaderboard. When it gets near to the end, usually at this point, people start merging teams, you know, in the last few weeks. And I got a few offers to merge. And at first, I thought, I don't want to join a team. I can do it by myself. But then everyone started overtaking me on the leaderboard because I was just by myself. And I thought, oh, maybe I've made a mistake here. So then when I got another team merge offer, I accepted it. And yeah, luckily it was a really great team. Like everyone else on the team is like a competitions grandmaster or master, and I learned a lot from them. And we got a silver medal in the end, and which I was happy with. Yeah, you can see who was on my team there.
Yeah.
These guys are all very highly ranked Kagglers. So I learned loads from that, and then after that, I thought this is great. You know, I'm going to apply all of the things I learned in this one onto the next competition. I just kept going.
That's great to hear. So when you jumped onto a Kaggle competition, at least for me, I had this like insane, overwhelming learning curve where I would like half uh, half as my way around learning things and like build one model in like 2 weeks. On Kaggle, you're forced to do that in like one day or like multiple times a day. Was that overwhelming for you, and how did you get adjusted to that Kaggler mindset?
Mm. Yeah, I guess I think it can be overwhelming, but I think for me, I kind of narrowed my focus quite a lot because, you know, machine learning is very broad and there's lots of different, depending on what you're applying it to, the type of algorithms is completely different, right? So I narrowed my focus first to NLP, and then I guess mostly I've been working with transformer networks, which just that one architecture is incredibly complex already. But um, if I just focus on this one thing, you know, then it narrows it down a bit. And I'm the kind of person who doesn't mind like repeating things and refining them. So uh, in fact, I quite enjoy that. I guess I'm a bit like a gradient descent in real life. You know, I just want to keep doing the same thing over and over again. But so that's more my approach to Kaggle. It's not about like exploring random things so much, although I think that is good too. Um, I'm I'm more of someone who likes to come up with like a method and refine it. So yeah, that's kind of how I approach it. I find a good baseline and I just keep running different experiments and different hyperparameters and improving on it, rather than reading a bunch of research papers and half implementing a bunch of half-baked ideas, because uh, I I don't think I would make so much progress that way or get such good results either. Although you would learn a lot that
I feel very seen, Adam. I feel very seen right now.
way. Yeah, I didn't mean it as a directed attack. It's something I've seen, you know, across the board. People have great ideas, but um, you kind of if you haven't implemented it, then you know, do you really know anything? I think.
So, as you were overfitting to the public leaderboard, how are you finding these ideas to iterate on? Was it through the discussions? Were you reading there and trying to go back implement them yourself?
Yeah. In some sense, I kept up with the discussions and the public notebooks to see what other people are doing. I'd have a few of my own little ideas as well, but uh, I think, um, yeah, I take a lot of ideas just from what other people are saying, because people on Kaggle, it's surprising, you know, in competitions how much people share. You would think people would keep it secret, right? But they share a lot of great ideas, and you can kind of just steal their ideas. But I think it's good to have a rule of never just fork someone else's notebook and run it, because you don't learn anything from that. And plus, I'm quite pedantic about the organization of my code in like a repo, like a Git repo. So if I'm copying and pasting someone else's code and stick it in mine, it's going to become a mess. So if I use someone else's idea, I'll either rewrite it from scratch or I will at least refactor their code. And when I'm done refactoring it in to fit in with my code, I kind of understand how it works.
That makes sense. I was trying to find this discussion post by myself, a bit of self promotion, sorry. But I had the
Yeah, it's all
exact same feeling where I was really surprised that top performers were really sharing their ideas and you could just take them and implement them. Although I even struggled with that, but everyone was really open, even my first competition.
yeah, it's great, isn't it? It it helped me a lot because when I do an experiment and I get a result, and then someone else shares a public notebook using roughly the same technique, but they get a little bit higher, then I know, okay, so they've done something that I haven't done right here, and then you can go through comb through their notebook and find every little difference between it and make little incremental improvements like that. I think.
Awesome. Thanks for sharing that context. I would now love to switch to talking about the competition. So
Sure.
I'll try to introduce the competition and please interrupt me whenever I mess up, which I do a lot. So as I understood, again, I haven't taken part because I'm too terrified of competing and I just ask stupid questions. uh, this, as I understand, was the fourth competition where you were again tasked with predicting relative rankings of toxicity. So, in historically, Kaggle has had this competition where you would tell if a comment is just toxic or not. Now they keep iterating on it. So now there's like levels to it where you have to basically predict with that. Emoji levels,
Right.
it'll be just numbers in the reality.
Right.
I was blown away to realize there's no data this time. So this
There's
time,
validation data, but there's no training data, right? Yeah.
yeah. So I usually start by talking about EDA, but there's no EDA here. So I'll switch to your write up, which I'll also put in the YouTube chat.
No, thanks.
But you use the Jigsaw 4 second and Reddit data. So could you please also talk about these data sets and how did you pick these?
Right. Yeah. So actually, I think in the competition overview, they recommend that you can use the data sets from the previous Jigsaw competitions. So even though there's no training data, you can just follow the links and get these data sets. But the challenge was that really that the other data sets are in, as you mentioned, a different format. This one's about ranking, um, whereas the previous ones were binary classification or regression. There was, you can frame this problem in all sorts of different ways. And I think the reason for this probably, and the reason why there's been so many of these Jigsaw toxicity competitions is that toxicity is a very like vague idea. What one person thinks is toxic might be different to what another person thinks is toxic. So it's quite hard to come up with like a consistent way of labeling toxicity. So I guess that's why they've had so many different competitions, and this is their latest attempt to define toxicity and measure it accurately. Um, and yeah, actually, should I share my screen? I've got a few descriptions of the competition
Please.
metric here. Yeah. Um, okay.
I can
Is
see these
that?
slides.
Yeah. Okay, that's great. Let's take a look at them then. Yeah. So this is my 14th place submission, as you already introduced, and as you already mentioned, this was the fourth Jigsaw toxicity competition,
Sorry,
and
let me please allow me to emphasize. I'm sure everyone in the audience would be aware of this, but gold in Kaggle is the like holy grail of achievement, and solo gold is like even one level higher. It's like one of the most difficult achievements one can achieve on Kaggle. Many people do it multiple times, but millions struggle with it. Adam got a solo gold in this competition, so really wanted to emphasize on that. Sorry to interrupt you.
yeah, sure. No, thanks for for bigging me up like that. Yeah, sure. If you just say 14th place, it doesn't sound that exciting. But yeah, it was a solo gold, so I was very
You're too humble.
yeah, I was ecstatic to actually win this. Um, what so yeah, in this competition, it was about ranked pairs of comments. So what that means is when the data is labeled, um, you can imagine they had some hired some annotators or they had some in-house data labelers, and each time an annotator is shown a pair of comments, and they have to decide which one of these two comments is more toxic, and each comment will appear multiple times in the data set, and also each pair of comments will appear multiple times. So a few different annotators will rank the same pair of comments. And I think usually in data labeling, what happens at this stage is if you have multiple data labelers labeling the same example, then you'll aggregate their labels in some way to make the labeling more consistent. So if it's a regression task, you can take the mean of their labels, or if it's classification, then you can do like a majority vote. But in this competition, there was no aggregation at all. So all of the individual annotations are preserved. And I think they mentioned that in the description here. They said, yeah, like each individual may have their own bar for toxicity. And we've tried to work around this by aggregating the decisions with a majority vote in the past. But many researchers have rightly pointed out that this discards meaningful information. And this is a bit vague, but I think what they're trying to say here is that for something like toxicity, what appears to be toxic to one person might not be toxic to another person. And especially some of the most like offensive, toxic things people can say are directed at specific minority groups. So if in the data labelers, there are only one or two people, are of this group, then of course they will find these toxic comments very offensive and rank them highly. But the majority of people might not know the meaning of these things, and they might not care, and they'll rate them lowly. So if we do a majority vote, then the
Could you
minority
please zoom in
opinions.
a bit?
Oh yeah, sure. Sorry.
No, please.
How do I? Why is it not zooming? Am I? Oh.
No, you're here. I'm. Is Command plus or Control plus not working?
Yeah. Okay.
Now
Yeah, I don't know. My hotkeys weren't working for some reason.
Okay.
Anyway, yeah. So basically, the point is, if you apply a majority vote to the data, then you kind of lose minority opinions. And I think the organizers wanted to preserve these minority opinions in the data set. So that's why it came out like this. But the problem with that is it means that there's like contradictions in the labels. Let's open this again. So I made a few small examples to demonstrate how it works. So the metric we're trying to optimize here is the average agreement with annotators. And for example, our model will produce some predictions. So these are some unique comments here, 1, 2, and 3. And we make a score, we predict a score for each one. In this case, I put the scores in a range of 0 to 1, but actually this wasn't required by the competition. You could predict scores in any range because the relative positions of the scores is what mattered. So I could multiply all these scores by 1,000 and I'd get the same score at the end. And the ground truth data has no scores at all. It just has these ranked pairs, right? And each row represents one one label by an annotator. So in this case, the annotator decided that comment 2 is more toxic than comment 1. And in this, maybe a different person here decided on this pair. And then the metric is how well my model's predictions match up with these. So for example, evaluating on this first one, we just check 2 versus 1. And here I rated 2 higher than 1. So I get this one correct, I get 1 point. But when we get to the bottom here, we can see that it's the same comments again, 2 and 1, but they've been rated in the opposite way. So it contradicts the first row. And our model can only make 1 prediction per comment. So we get this one wrong. And actually, it's impossible to get the first one and the last one correct at the same time, because you can only predict 1 score here. So in this little example, 0.75 is the maximum score. 1 is impossible. And I think in the validation data, yeah, I think CPMP had a post about it here, that some other people calculated this before, but he did a good notebook at the end where he calculated taking into account the contradictions, what's the maximum possible score on the validation set. And it comes out to be about like 82, 83%. This is the best possible score on the validation. As for the public and private leaderboard, we don't know what the best possible score is.
Hmm.
But the public leaderboard one, the best possible score was a bit higher because you could see some people got higher than about 80%, right? It went up to 90 something here. So this is, I think, one of the major problems that people faced in this competition was that the validation set and the public leaderboard didn't really agree at all. The range of values seemed to be completely different, and it's often, I think there was about 50 discussion threads where somebody would say, "My validation score went up, but my leaderboard went down. What's going on?" That was the main thing in this competition.
When I looked at the private leaderboard, I thought this was like a second stage evaluation. That's why there was such a big shakeup. But then I realized no, there was an insane split.
Right, it's just an insane shakeup, right? Yeah, you can see like most of the people here moved up over 1,000 places at the end,
Yeah,
except for Manuel here, who seemed to have done well on both leaderboards. But that's very rare. Most
that
people,
still is crazy. 40 positions up is still a lot.
right, in a normal competition, you would consider that a
Yeah,
big shakeup. But in this one,
yeah,
it's like he's barely moved at all, right? The guy who won with almost 2,000 places and amazingly only 2 submissions
two
into the
submissions.
competition. Yeah, that was crazy, right? But yeah, me as well. I was in position like 1,500 on the public leaderboard, and it was mostly just faith keeping me going in this competition. Um, I went into the competition determined to trust my cross validation score. Like that was my mindset because in the previous one, I had worked on the Chai Hindi and Tamil competition,
Mhm.
and in that one, I did quite well in that one actually. I got a silver, but I looking through my submissions, I noticed that there was one that had a higher cross validation score and a higher private leaderboard score. And if I had chosen that one, I would have got a gold, but I didn't pick it. So I was kind of angry about that. And I thought in the next competition, no matter what, I'm going to trust my cross validation score and I'm going to ignore the public leaderboard. So that's what I did in this case, but it was a real like test of faith on trusting your cross validation score. This one,
It did work out really well for you.
yes, yeah, it did. I've got a lot of faith in cross validation now after this. So that's about the metrics for this competition. So as you mentioned before, there was no official training data in this one, but we could use a lot of different data sets, and particularly the previous Jigsaw competitions had a bunch of data sets, and you also mentioned the Reddit one too. This one is, I think the comments come from Reddit, and then they've
Mhm.
been labeled with a value between -1 and 1. And I also use this one, Offensival, which I think it comes from a conference called maybe SEMeval, Semantic Evaluation, and it's a massive data set, like 8 million examples, and the labels I think are the average of some machine learning model predictions. So this one was very large but kind of noisy because it's not labeled by humans, I think. Uh, a, a difficult point when selecting data sets was that the labeling is different on each of them, right? In this one, we want to predict some rankings, but we have regression data sets and we have classification data sets, and we need to kind of make the labels work for us so we can predict things in this range.
Hmm.
Uh, so we had to come up with ways of like converting one set of labels to another one. I found it was pretty easy to create more ranking pairs because, like the validation set, because if you have data set in this format, you can
Mhm.
easily just pair them up, right? And then you can create data in this format, which works, but not so well. And another method.
Sorry, may
Go
may
ahead.
I ask how are you doing that? So I'm looking at the I switched the screen sharing. I'm looking at the offense eval 2020. How are you
Mm,
creating these pairs? Because I believe these didn't have four evaluator rankings. Sorry if it's a
right.
new question.
No, that's fine. I think so. I actually the version of this I used was from. Oh no, sorry, this is the wrong competition. Uh, well, I don't think I'll be able to find it. But anyway, the version of this data set I used was a pre-processed one someone had uploaded to Kaggle already.
Got it.
And I think I mentioned it in my solution that it had labels that were like an average of annotators. So I was just using it like a regression data set, really.
Found it. It's by Arrowhead. That's their username.
Right.
And I believe they've already pre-processed it. Yeah. You can see the description. I'm just quickly sharing it for the audience.
Okay. Yeah. Thanks. Yeah. Yeah. It was quite hard to keep track of all the data sets in this. I felt like this was the main thing to focus on here because, like how I mentioned, different people have different senses of toxicity. I felt maybe we
Hmm.
could simulate that by using different data sets that have different labeling schemes, and then if you ensemble them together, at the end, it's like finding an average of different people's opinions, using but with data
Makes
sets
sense.
instead of people, right? So that was my original idea, that I would train a bunch of different models on different data sets and then take the average. But in the end, it was a little bit different. But one other pre-processing thing, which I took from another public notebook, was using the data from the first Jigsaw competition. So this one had it was binary classification, but with multiple labels. So each text can have it can be classed as toxic or obscene or an insult
Hmm.
or any of these, right? And what people were doing was just taking the sum of these labels and dividing by the number of labels. So you can just add up all the ones. And in this case, I've also weighted severe toxic as 2. So that's why there's a 2 here and it's a 7 here. And then you divide by 7 and you just get a score like this. And then you can use this like a regression target. And when I saw this, I thought, this is too crude. Surely this won't work. But it worked quite well, actually. So I stuck with it. And I noticed some other people tuned the weight of each of these classes as well. So they didn't just use one, they multiplied each one by a different value. But because I was busy iterating on data sets, I didn't really have time to tune these weights. But given more
Hmm.
time, I think that's probably another way to get a little advantage as well. So basically, I tried to make as many data sets as I could into regression data sets or ranking data sets, because classification was a bit harder to use here.
Okay. Makes sense.
Yeah. And for the validation data, we already talked about how it works, but creating a k-fold cross-validation split was kind of difficult here as well, because the same text appears in a bunch of different places and the same pairs of text appear in different places. You have to be careful not to leak texts into different folds. If you do just a simple random, like naive split, then you'll end up with the same texts and the same pairs of texts in both in your training and in your validation folds. So I use this method, this union find algorithm, which I think I've got it open here. Yeah, it was this notebook was by this guy Column, which it's a really nice simple implementation, and you end up with folds that don't leak texts. So that was good. So I used that, and I didn't do any aggregation of the validation set. I mentioned this because I noticed a lot of competitors did in this one. Some people did a majority voting on, or just removed disagreements in the data set. And I think it can work well because you kind of removing the noise from your data set. So if you're training on the validation data here, then if you do majority voting, you're kind of getting a stronger signal. But the downside is that the test data has these disagreements in. So if you remove them, then you're creating really like overly optimistic cross-validation scores, because you've removed all of the difficult parts from the data set already. So you get a great score on cross-validation, but it might not translate to the private leaderboard. So I didn't do that. I kept the data set as it was. for loss functions, I mentioned these because these ones are standard. Of course, if you're doing, regression, you use mean squared error. I guess people know that. This margin ranking loss was new to me in this competition, so I've included this here. And actually, there's a implementation of it just in PyTorch already, so I didn't have to implement anything myself. And basically, how it works, it's perfect for the validation set in this competition. You have to do 2 forward passes for every backwards pass, but you have text 1 and text 2, and you generate this x1 and x2, and then your y, the label here is 1 if text 1 should be ranked higher, and -1 if text 2 should be ranked higher. And then what happens is, if you rank them in the correct order, then this expression will evaluate to a negative number, and then the max function will return 0. So if you rank them in the correct order, you get 0 for loss. But if you rank them in the wrong order, then this will be a positive number, so this will be your loss value. And also there's this margin, so you can add like an extra penalty to the loss. And it also means that even if you rank them in the correct order, but these two values are too close together, then this difference will be small, which means that the margin will still produce a positive value. So it kind of encourages your model not to produce these two values too close together. There should be more separation between them. Otherwise, you'll still get a loss. So you can use this one to train on the ranked pairs, even though there's no like explicit regression target values, but you can still fit a model that will produce a single numerical value for each text, which
Makes
is really
sense.
cool, I think. Yeah. As for model architectures, I didn't really do much experimentation here. I guess, as I said earlier, I kind of like just narrowing my focus and refining something. So I kind of went with the, out of the box model architectures, which in NLP these days, basically it means you're using some BERT variant. If you're doing any kind of classification or regression task, you should be using some BERT variant. If it's a language generation task, then maybe something different. But yeah, in this competition, for sure, I ended up using various BERT variants. Roberta is always a good starting point, I think. Rather than the vanilla, but this one generally does better in every way. So anyone else who's thinking of starting an NLP Kaggle competition and you want a strong baseline, just go with Roberta. It does well on everything, and it's not so big. Like you can fit it easily on your GPU and run some experiments, right? I also used Deberta quite a lot, but Deberta is another BERT variant. This one has, I think they call it disentangled convolution, which is like a modified, disentangled attention, not convolution, disentangled attention, which is a modified attention mechanism, which practically speaking, it often or sometimes does better than Roberta, but at the cost of an increased memory footprint. So if you're like me and you do most of your training on Google Colab or Kaggle, you only got 16 gigabytes of space. If you're trying to load Deberta large, then you're going to be training with a very small batch size, like 2 or 4, which is fine. But considering some of the large data sets I was using in this competition, it meant that some of my training runs would time out. In like after one epoch, it would be 24 hours would pass out, and it would time out.
Interesting.
So, yeah.
There's a question in the chat.
Oh, go ahead.
Sorry. They're just asking if we were just using Kaggle GPUs or external resources as well.
Yeah, well, just Kaggle and Colab Pro. So I just not even Pro Plus, just Colab Pro.
Wow. Okay.
But, yeah, I don't really have access to any other GPUs at the moment, and I use my Kaggle quota up every week, and then I went over to Colab.
Okay. Sorry, you were talking about Deberta eating up all the memory and time.
Right. Yeah. So Deberta ate up most of my memory. Remba also eats up a lot of memory. Um, this is, I think, the main difference of Rembert compared to VanillaBert is they, uh, what's it called? Decoupled the input and output embeddings. So this is another optimization that uh, potentially improves the performance, but comes at a cost of increased memory. So I was in a similar situation to Deberta. You can only train with a very small batch size. Another cool thing about Remba, and the reason I included it here, was that the pre-trained model is multilingual. It was trained on a bunch of different languages. And I found out about this one in the Chai Hindi and Tamil question answering competition, where it performed really well. And I noticed one of the data sets in this competition, the third Jigsaw competition, was a multilingual data set too. So I thought maybe I can fine tune this multilingual checkpoint on this multilingual data set, and I'll have another cool model to add to my ensemble. But I didn't really get that data set to work because it was binary classification. But I found that Rembo worked well anyway, just on any data set. And actually, I think this was my best performing single model. So yeah, in the future, I'll probably try Rembo as well. Those were the only ones I ended up using in my final submissions. I think probably if I had added some other different architectures, I could have improved my score a bit more. But I was mostly, as I said, I was mostly focusing on using different data sets. So I didn't really explore this very much. So what I did explore was different fine tuning on a bunch of different data sets. And I've called this strategy I came up with here multi-stage fine tuning, but I don't know, for lack of a better name, I don't know if this is just something I tried and it's, doesn't work in general, or maybe there is some research paper published where they've done this but called it by a different name. I'm not sure. If somebody does know, please send me the paper, I guess. But the idea is basically to just add more fine tuning stages. So I in NLP these days, I guess most people know that we have this paradigm of pre-training and fine tuning. So usually you start with a pre-trained transformer that you download off the Hugging Face hub, and it's already been pre-trained on the general masked language modeling pre-training objective, or maybe an auto-regressive one, depending on the architecture. But then you take that and you fine-tune it on your specific task, and you get a better performance than if you had just directly trained a model that had randomly initialized weights. But again, in the Chai Hindi and Tamil competition, I think several other people found that you got better performance if you first fine-tuned your model on a different data set of the same task. So in that competition, it was question answering. So if you fine-tune on a English question answering data set and then fine-tune again on the Hindi and Tamil question answering data set, you got a better performance. And I thought, well, that worked well with 2 data sets. This time I've got loads of data sets, so why don't I just keep doing it? So that's what I did. I tried fine-tuning on each of the data sets individually, and then I found the best way to stack them was to order them from like the worst performing one to the best performing one in terms of their performance on the validation set. So I started with the offensive val data set, and I got about I think 68% on the validation set, and then the second Jigsaw data set, and then that improved the performance to about 69, and then the first Jigsaw data set, the performance up to about 70, and then finally do a like a 5-fold split on the validation data. And
I think in computer vision, this is called as progressive learning.
oh,
I
really?
think that's the term we were looking for, right? I
Yeah.
think that might be it.
Okay, cool, great, thanks. Yeah, I don't know very much about computer vision, so Yeah, I hadn't heard of that before. Cool. So progressive learning, are we calling
I
this?
don't know much about machine learning broadly, so I might be totally wrong, but
Yeah.
that's
Okay.
up to
Well,
you.
thanks for giving me the name anyway. I'll look that up after this, and yeah, maybe we can call it that instead. But yeah, that's what I did in this case, and I found it worked quite well for this competition, and I found it was possible as well to switch between the data sets with regression targets and the data sets with ranking paired data, because you don't need to change the model architecture at all to do that. It doesn't work so well if you try and switch between that and a binary classification data set, because you have to modify the last layer of the network. And you can do that, but I found I lost some of the performance when I modified the last layer.
Hmm.
So yeah, I just stuck with mostly regression and ranking data. Uh, yeah, so here's some of my results. These are some of my better performing models on each sample of the data, and I've ordered them by cross-validation. I won't read all the numbers out; it's not very interesting. But the idea is just for to show basically the lack of correlation between these two. That my best cross-validation model had not very good public leaderboard score, and then this one, which had a complete garbage cross validation score, was my highest score on the public leaderboard.
Hmm.
And yeah, this particularly this combination of TF-IDF for encoding and then a ridge regression was what a lot of people used, and it turned out that this one did really well on the public leaderboard. It overfit the public leaderboard really hard. Um, so if you ran on the validation set, you would see there is something wrong because the validation score is really low. And I noticed this when I was looking at the public notebooks in this competition. Maybe I can find them actually. I think some of them have probably disappeared now, but I guess if you order by um, what is it? Best score, right?
Best
I
score.
think it should. Yeah, it shows the highest. Like all of these ones. Or I mean, even here, I think it became a bit of a joke at the end of the competition, right? Even in the title, it's just overfitting the leaderboard. That's what they were trying to do, but uh, I'm not sure why people spent so much time overfitting. But anyway, you could get like
Even
a
if you,
ridiculous. Sorry, go
I
on.
was going to say, even if you go to the leaderboard, it's quite visible there.
Right. Yeah, I think that's also true, right? You see these crazily high scores. Um,
0.91 and the private was 0.81, some digit, if I
Right.
remember correctly.
The top top private score was 0.81. And then on the validation set, you got another set of numbers. They were more like 0.7 something. But I think a lot of these models that were getting like 9.9 on the public leaderboard, they still had less than zero point 0.7 on the validation set. They were like 0.65 or 0.67, something like that. But it seemed like a lot of people didn't really care. I saw a lot of threads in the discussion where people would kind of try to explain it, like why is this doing so well on the leaderboard? And I thought many people were kind of asking the wrong questions. They would say something like, why is ridge regression so much better than transformer networks in this competition? But I think that question kind of already assumes the answer, which is that you think ridge is better. But the real question is why does ridge perform so well on the public leaderboard but not on the validation set?
Hmm.
Um, so I think, yeah, really, this was a competition about the validation set. Um, and I think, yeah, I've only got one more slide here, which is just about how I ensembled my models. And it was fairly simple, just a weighted mean of the model outputs. And I used Optuna to find the weights. It was my first time trying this library. I'd heard a bunch of people recommending it, and it's pretty great, I think. It's you just define the objective you're trying to maximize or minimize, and it just let it run, and it finds some great weights. So I'll probably use it in the future for hyperparameter tuning and things like that too. And for selecting which models to include in the ensemble, I used a kind of simple I guess, a greedy algorithm where in a series of rounds, starting with my best performing single model on the validation set, then I
Hmm.
would try adding each of the other models in turn, and whichever one increases the outer fold score the most, you take that one, and now you have two models, and then you do another round and you add a third model, and you keep adding one model at a time until the outer fold score stops improving, and then that's the final ensemble. So that with this one, I got up to about 0.719, almost 0.72, and this was only like a slight increase over this, but um, in a Kaggle competition, it's still this like uh, 0.05 increase is still significant. Of course, if you were going to deploy this model into production, you wouldn't add 6 transformer networks for that small increase. But if you're in a Kaggle competition, it's worth it, no matter how inefficient the runtime is, as long as it finishes in under 9 hours. It moves your position up the leaderboard. And I think
That's
that.
also that's
So
also a
go ahead.
very interesting constraint, no? Because many people, nothing against them, many people get exposed to large computational resources and they use a bunch of GPUs. For your
Mm.
solution, you managed to do it just using Colab and Kaggle, which is within the reach of many people. I'm spoiled with so many GPUs, which I absolutely don't use, but that also goes to say how much of a nice solution that this is.
Oh, thanks. Yeah, yeah. I mean, I wish I had some nice GPUs like you. Like, we were talking about your shiny computer earlier, but um, yeah, I guess you make do with the resources that you have, and I for the last few years, I guess I've been training transformer networks mostly on Colab, so I know a few tricks. You use mixed precision training and
Hmm.
gradient accumulation and things like that to compensate for the fact that you don't have much space, and you can still get pretty good results. It depends on the competition, of course. Some competitions the computation is like the main thing, and in others it's not a big factor.
Yeah.
And I think in this competition, it wasn't such a big factor actually. As long as you had access to Colab, I think you could do well in this competition. And I think this ensembling technique paid off for me because even though it only slightly increased my score, I only barely got a gold, right? So if I hadn't if I hadn't done that, then I would have been down. I would have lost a bunch of places because the scores are all very close together here.
Yeah.
Um, so yeah, it all paid off in the end. So um, I'll probably use this approach again in the future.
That's
Um,
awesome to hear.
yeah, that's
Um,
all I had for slides at the moment. But
Sure. I wanted to come back and ask how were you tracking your experiments and how were you organizing your ideas?
oh yeah, that's a good point. So in this competition, I started using weights and biases for the first time, or maybe I used it a little bit in the previous competition, but I found I quite liked it. It's very straightforward to use, right? You just had a few extra lines of code, and it logs all of your parameters and creates all these nice visualizations and stuff. So I started using that, and I found it helps a lot. My my basic method of recording is just like a spreadsheet, like a Google sheet, and I just have some columns for the cross validation and the leaderboard scores, and a little space for notes, and I just one row per experiment, and then on weights and biases, I created a group for with the same row index, and then it's easy to match up the experiments like that. And also important too is naming the when you train the model, the weights files, you need to label them with the same group as well. I've learned this kind of thing the hard way because in earlier competitions I would just sort of train stuff and think, oh, it's fine, I'll remember it, and I would give things random names, and but then 2 months into a Kaggle competition, you're looking back through the notes, you're like, oh, that model, maybe I can include this in my ensemble. Where is it? Where are the files? I can't find the weights. And then, okay, I'll retrain it. But now I didn't log all of the hyperparameters correctly, and I can't reproduce it. I didn't set the random seed properly. It, you know, it becomes a nightmare. So I've learned through experience that it's important to consistently name things and label things and log all of the parameters, even if they don't seem important at the time. Um,
No, no, thanks for the shout out as well. I'm sure the team will be happy to hear that. Awesome. I don't need to summarize the solution. Usually, I try to summarize just for my own understanding as well. It was very well documented. So I'll move on to the last few questions that I usually ask. What's next for you? Are you looking at more Kaggle competitions? A bunch of them just launched. Birdcliff, H&M, Whale. I guess Birdcliff would be NLP-ish. There's also another NLP one going on. Which one are you looking at?
Right. I just started working on the feedback prize competition actually, which is another
Okay.
NLP one. Yeah, I got uh, told about it by Panel Singh, Mr. Know Nothing on Kaggle, who we worked together on the Common Lit competition before. He contacted me about this one, so it seems like a really interesting competition. It's another one that's kind of education related, so it interests me as well. But this one's about trying to find sections in a student's essay that identify different parts of an argument. So is this section a evidence or a counterclaim, or is it the conclusion? And you have to highlight different parts of the text. So I started working on this one. It seems really interesting, but it's quite a difficult task. And outside of that, like in future, I do want to try some non-NLP competitions too. Like really, I'm obsessed with NLP. So if there is another NLP competition, I usually get kind of dragged into that because it seems the most exciting. And that's my main. Oh yeah, here he is. Yeah, yeah. It's my main criterion for like determining a competition is what's the most like interesting one, because it's something that if I commit to it, then it's something I'm going to be working on for 3 months. And if I'm not interested in the content, then I'm going to get
Yeah.
demotivated and I'm not going to get to the end. I'm not going to do well. So I have to be ultimately have to be interested. But I've seen like advice from other Kagglers on this kind of topic is they often say pick the competition that you're going to learn the most from, right?
Hmm.
I think that's probably good advice, but I think it's often interpreted to mean something like pick the one that you currently know the least about so that you have the most room to learn. But I don't know if that's necessarily the one that I would learn the most from, because as we talked about before, like if you don't know anything in about this area, then you might just
Yeah.
make a bunch of like half-baked ideas and not make any progress. But if you already do know something about it and you are already interested in it, you can use it as an opportunity to like refine your skills, which is another kind of learning, I think. So even if it's just another NLP competition, I think I can still learn a lot from it, you know. Of course, I haven't solved NLP yet or anything, so there's lots of room.
Makes sense. Thanks for the honest answer. This is usually the last question I ask. What's your best advice to anyone who's starting their journey in Kaggle?
I guess I'd say kind of well partially what I said in the last answer, which is just find things that seem interesting. Don't like make yourself try and make yourself do things that you aren't going to be interested in, because if it's not fun, you won't keep going. And I guess practically trust your cross validation score. I know that's not a very novel answer from a Kaggler, but yeah, if this competition has shown anything, it's that chasing the leaderboard, it doesn't end well. And if you at the start of the competition, you've got to set up a good, cross validation split and stick to it, and that will give you like some yardstick to measure all of your submissions against. So it's the most important thing to get right at the start. And after that, track your experiments and carefully label and organize everything as best as you can, I think.
I wanted to point out it extends to all competitions. The TensorFlow Great Barrier Reef one just ended, and
Ooh.
The it was really funny in hindsight because let me find that thread. Um, just give me 1 second. It was really funny. I'll try to explain the context. So at that time, Kishan Ha was 150th on the leaderboard, and he made
Mm.
this post saying, "Can't wait to learn from other people." And he's first now, so that's absolutely incredible.
Looks like he learned very quickly how to get there. But yeah, yeah, it's a big shake-up. I mean, yeah, because the other shake-ups in this competition weren't so big. Just 150 is huge in that one. Wow. Yeah,
Awesome.
I think it's often the case, right?
Yeah,
That if your validation score, if you have a good validation score, even if it's not good on the leaderboard, it'd still be good.
absolutely. I'll wrap up here by mentioning your Twitter profile, which is again at a Montgomery underscore. On there, you can find Adam's blog where he writes incredible blog posts. I read about his journey here. I also read about how he was trying to create this predicting level of English test that he spoke about, and how he basically has gone about creating different projects. I'm sure he'll keep writing this, so you can check this out as well. He's also on LinkedIn. You can just look him up. You'll be able to find him there. Any other platforms you want to mention?
No, that's it really. I don't use social media so much, but yeah. Thanks for mentioning my blog. I write on there occasionally. So, yeah.
Awesome. Thanks again, Adam, and huge congrats to you for the solo gold and competitions master. I'm hoping you'll soon reach the golden color on your profile.
Yeah, well, maybe one day. I think that'll take quite a while longer, but yeah, thanks for having me, and it's been really fun to talk about this.
Thanks, and thanks to everyone who joined us live. I'll end the live stream now.